Hello everyone and welcome to a new IBMI RPG sample video. Today I'd like to talk about creating SQL tables and how we can add audit columns to our tables which can be used to store information about the records. For example, sometimes we need to know who modified or inserted a record, when, which was the last operation performed, and which job did it, for example. I think this is something very useful because many times we need to know that, and then we need to use the journal. And this is sometimes impossible because the operation was too many time ago, or simply I cannot use the journal for somehow, and also the journal is slow and sometimes it's hard to query. So let's go. Well, today I'm going to do all the operations with SQL from Visual Studio Code. You will see how simple. Once connected to our IBMI, we must open a new text file. Then we will select the language, in this case SQL, and well, in this window we can write our statements and we can run them. For example, imagine that we need to write a simple query to a table. Let me write it. For example, and then we can use this button to run the statement, or of course we can run and explain, or simply explain if you need it. Okay, so as I know the keyword shortcut, I'm gonna use it, and as you see, I'm here getting the results. Well, let me close it and let's start with the creating of our table. Well, the first thing I'm gonna do is drop in the table. I don't know if I have it. Drop table. Let me create this table. Okay. Okay. And okay, let's create a new table now. Create or replace table. Well, the table is gonna have two fields. The first will be an ID. As you know, we can have two different names for the same field. First, we can have a long name, and then we can have a short name. This name is usually used in native operations on the IBMI, but today we can also use the long name in our programs as an alias. If we don't specify a short name and the long name is longer than 10 characters, the table will store an automatic short name for that field. In this case, the ID is gonna be an integer. Let me write it. For ID, this is the short name. That is gonna be an integer. And we want that DB2 generate a different and unique number every time we add a new record to the table. And this is very cool because DB2 do it automatically. We don't need to store the last number in a different table or look for the last number stored in that column before adding a new record, nothing. For doing this, we only have to add a generated always sentence this way. Okay, and we write start with 1, increment by 1, and no cycle. Okay, well, this means that the ID will start with the number 1 and it will be incremented by 1 in every inserted new record. And as we have written no cycle, then the number will never be initialized to 1, not even if we get to the last number. In that case, we will receive an error. Okay, I'm gonna add a new column that is gonna be a name. Name for name. This is gonna be the type and the default for this field. Okay. This way, if we doesn't write a name, the default is gonna be empty. Cool. Well, after that, we're gonna set the ID as the primary key this way. Okay, and we end the create table statement adding a record name. Well, this is not necessary, but if you are going to use the table with native I/O operations, maybe you will need it. Okay, let me run this statement. And as you see, statement executed with no result set return. Well, it is created. Okay, so if I see the table is created, but now it's empty. Okay, well, now how can we add a new record to this table? Well, for that we can use insert in two different ways. The first way is this: insert values, and I add here the different values for every of the column of the table. Let me write it: default and first. Okay, notice that it is important to set the ID as default, because as it is a generated always column, you cannot set a value here, so you must use default. Let me run the statement. Okay, now we have one record, and as you see in this column I have the number 1 because it's the first element inserted in the table. Okay, well, the other way for inserting a new record is this: insert, and now I have to write the different columns that I'm going to use and the values. Okay, in this case I'm not using the first column because it is an automatic column, and if I insert this new record, this is what I have. Okay, so this way the first column value is set automatically as in the other way. When we have generated always columns, this is the best way for adding information to our tables. Okay, well, now imagine that we want to remove the first record. Okay, okay, if I run this and I see what's in my table, you see I have only one record with the number 2, and if I insert a new one, this is what I have in my table. Okay, so you can see that the removed ID is not used anymore. Okay, well, now let's talk about the audit columns. What is an audit column? An audit column is a field that we can have in our table that can store information about each record. Information about who inserted the record, or when it was inserted or updated, etc. I'm going to add some examples. Imagine that we want to store the last operation made in every record, an insert or an update, and we want it generated automatically. For that, we can do this. Let me close this and let me change the definition of the table. Now we are going to add this. For example, this is going to be 1 character. Okay. Well, now I want to store the user that made the operation also automatically. For that, we have to do this. User, for example, for Okay. Well, what about this storing the job name? Well, we can add it to job name for okay. And for example, let me add the last one. Let me store the timestamp of the last operation made in the record. Timestamp for timestamp okay. Well, as you see, I'm now storing not only the information that we want to have in the table, also I'm storing audit information of every record. Okay. Well, let me run the statement. I'm replacing the table for this new structure. Okay, I'm still have all the other information, but the new columns are empty. Okay. Well. Okay, now let's add a new record to see the information that the IBMI is going to store in it. Okay, let me, for example, add the fourth. If I run it and I see what's in my table, well, this is what I have. I have here the fourth, the number, the ID automatically set, an I here because the last operation in this record has been an insert, the user, that is my user, the job name, okay, and the timestamp where the operation was made. Okay. As you see, all the information is generated automatically for the last operation of insert that has been made. And this is information that is very useful. I think it's great. Well, for example, imagine that we want to modify the last record, okay, an update. Well, for example, we can do this. If I run it and I see what is in my table, now I have all the fours. Now the last operation was an update, the user is the same, and this is the job name. And now the timestamp has been changed because the last operation made is an update. Okay. Well, very cool. Now let me say something more. Why we should have all these columns visible for every query made. As you see, I have made this query, select all from the table, and I get all the different columns. Okay. Wouldn't it be better to hide this information and only make it visible when it is really required? Well, yes, to do this, we can make these columns implicitly hidden using this. Let me change this, and we're gonna change our table this way. Okay, we're gonna have these columns implicitly hidden. Okay, so if I run this, okay, and I run this to see what's in my table, this is what I get. only the two first columns. Okay, so this way, if we want to see the information stored in the table, this is the only thing I'm getting. So the audit columns are not visible unless we require them indicating the different columns names that we want to get. For example, we can do this. Select for example, the timestamp, and this way I'm getting this column. Okay. Well, okay, one more thing. Maybe you are wondering if a physical file could have audit columns. Well, the answer is that you cannot create a physical file with audit columns because you cannot define them in a DDS. But it is possible, but I don't recommend it. It is possible to add audit columns to a physical file without converting to SQL using alter table. So for example, you could use alter table, insert column, and add all this information of a new audit column. Okay, in these cases I prefer to first convert the physical file to a table and then insert that columns. Okay, well, as you see, this way we can have a lot of information in every record that can be very useful, just adding one or some more fields to our tables, depending on the information that we want to store. I think that it is very cool because many times we want to know who touched this record and when. Well, this way we are going to have that information and we are not going to need the need to go to the journal that is slow and many times doesn't have information that we need. And of course, it is not as easy as this. Okay. Well, I hope you liked the video and that it was useful to you. As always, remember to like and subscribe if you are already. See you on the next video. Thanks for watching.